How do you store currency in Python? This is one of the most common interview questions that beginners can face. This video will cover the decimal module in Python, including rounding decimal numbers, and their application in SQL. The first thing that comes to mind is to use float numbers. So let's try using it. Well, let's run the code and see what happens. Using floats is not the best choice for storing currency because of the way floating point numbers are stored in memory. Floats are not precise and can lead to rounding errors, like this. A better approach is to use integers and store the amount in cents. For example, $1 would be stored as 100 cents. This approach eliminates rounding errors and works well in most cases. This method works well, but it can be a bit complicated to work with. The best choice for storing currency is the built-in decimal module. The key benefit of using the decimal module is that it allows you to perform arithmetic operations without losing precision. Let's try the same example using this module. As you can see, everything works as expected and we don't lose precision, and this is what we are looking for. Sometimes you have to deal with external data like floats or strings that have a different number of decimal places than you need. Or after some arithmetic operations you get a number with a lot of decimal places. In this case, you may need to round them. So how can you round a decimal number in Python? The first thing that comes to mind is to use the round function. Let's try. Everything works, but there's a catch. If you don't pass the second argument to the round function, it will return an int type, class int. To avoid this, you can use rounding methods from the decimal module. For example, getContextPrecision. This method is simple, but it has its drawbacks. It sets the precision only for arithmetic operations result in the whole script. A better approach is to use the quantize method. It rounds a number to a fixed exponent. For example, we have a number 2.45. First, we need to create a decimal object with the exponent that we want to round to. And then we need to specify the rounding mode. In this case, we use round half up. Round half up. The round half up mode rounds to the nearest with ties going away from 0. So if we want to round a number with 5 at the end, it will be rounded up. If it's less than 5, it will be rounded down. So basically, it's equivalent to the round function. But it's better to use quantize with the decimal format. Let's consider another mode. Round half even. This mode is the most commonly used in financial applications. It rounds to the nearest with ties going away to the nearest even integer. So for example, if we have 2.5 here, we will have 2 as a result. If we have 1.5 here, we'll have 2 as a result. And if we have 3.5 here, there will be 4 as a result. In other words, round half even rounds 0.5 up if the non-decimal part of the number is odd, and rounds it down if the non-decimal part is even. The round half even mode is considered the most fair way to round numbers, because when dealing with large sets of statistical or scientific data, traditional rounding on average biases the data upwards, while round half even reduces upward skewing. SQL has a decimal data type as well. It is used to store exact numeric values, but its syntax is a bit different. Let's define a column with a decimal data type. I'll use PostgreSQL with dbeaver as a client. I'll create table products with ID, primary key, name, and decimal. The price column is defined as a decimal with 10 digits in total and 2 digits after the decimal point. Now let's insert values. And now let's select all products from products. Okay, everything works. Maybe now you have a question, will this work with the decimal module in Python? Well, the short answer is yes. The more longer answer is some DBs have a decimal data type that is compatible with the decimal module in Python. But you need to check the documentation of the DB you are using. Here I have a simple Python script that connects to the database and selects all products from the table. Let's check if the price column is a decimal number. Well, products, 1, Xiaomi, decimal, 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 and prices decimal as well. Well, everything works as expected. The price column is a decimal object. Now let's check if we can perform error-free arithmetic operations with it. Let's, for example, sum every price in the table and print the result. Print sum prices and sum prices. Now let's run the code. And the result is exactly what we expected. We don't lose precision and everything works. But in some DBs like SQLite there is no such thing as a decimal data type. So to make the same script work with SQLite, we need to find workarounds and make crutches. Let's take a look at this same script but written for SQLite. Let's run it. And well, everything works. But as you can see, we need to register the adapter, register the converter to work with decimal objects. This is a bit overcomplicated, but it works. Thank you for watching. All links to documentations are in the description down below. If you enjoyed this video, please leave a like and subscribe to the channel. If you have any questions, feel free to ask them in comments section. And bye!